When we talk about creating models given data sets, the most common types of models that are occurring in the world would be linear, quadratic, exponential type models. Because these are the most popular, most common types of models, students are going to be expected to determine which model is appropriate given a set of data on the AP exam. So there are a few strategies and methods that can be used to determine whether or not you have linear, quadratic, or exponential. So one example is that you've got, one example is that you've got maybe a graph with this data, or perhaps not necessarily with the line, but maybe these blue dots. Or perhaps they give you these blue dots as ordered pairs. So 0, 1, 0, 1 is right here. So you could look at the data numerically, or you can look at it graphically. So 4, 5 would be right here. So you can see 6, 6.4 is right here. 8, 8.7 is right here. And then what type of function does the data model? And that's where this line comes in. And you say that that is looking linear. So that's a constant rate of change. You have a relatively close to a constant rate of change. Now, when the data has this symmetrical shape going on and you have a maximum or a minimum, that is going to be your quadratic model. So I like to take the data table and I like to plot the points and see what's happening. Exponential is where, and we've looked at this quite a bit in the last few lessons, is we've looked at the output values being proportional, where each successive output is, approximately the result of a repeated multiplication. So because this is data in the real world, it's not going to be perfect. So for instance, and I'll just use the linear as an example. And I'm not going to do this for all of them, but I will show you the linear as an example. To get from 0 to 2, you add 2. To get from 2 to 4, you add 2. 4 to 6, you add 2. And 6 to 8, you add 2. That's your change in x. And your change in y is going to be 1.6. And then it would be 2.4. And then it would be 1.4. And then it looks like it would be 2.3. So this right here, 1.6 divided by 2, it's 0.8. 2.4 divided by 2, that's 1.2. 1.4 divided by 2, that's 0.7. And 2.3 divided by 2, that's going to be 1.15-ish. So you can see that these numbers are not the same. So is this a constant rate of change? No, it's not perfect. But again, we're talking about data in which we're going to create perfect, and that perfect is the model. So here's the model, okay? That's the model. But the actual data is not perfect. The actual data, you're falling either above or below that model. Very rarely will you be perfectly on the model. So does this represent an absolute constant rate of change? No, but it is relatively constant. You're going between 0.8 to 1.2, back to 0.7 to 1.15-ish. So very close. You can find an average here and say it's somewhat constant. And that's what a model is all about, is that you're just trying to find a best fit. Which one, linear, quadratic, or exponential, best fits the model. So in the next video, what we're going to be doing is we're going to be looking at some data, sketching the scatter plot, and then determining from the scatter plot what type of model is best fit. And then after that, we will talk about residuals and how we can determine from a residual plot whether or not our model is appropriate. So I'll see you in the next video.